Hello, in this lecture we find out the radius of the semicircle. In the drawing we have a semicircle. Line segment PA is tangent to the semicircle at point A. We know that line segment PA equals to 6 units in its length. And we also know that line segment PS cuts the semicircle at points Q and S, and we know that line segment PQ equals to 4 units in its length, and we also know that QS equals to QC, and we also know that this angle PAB equals to 90 degrees in its size, and this angle SQC also equals to 90 degrees. Again, our mission is to find out the radius of this semicircle. So first of all, I will present to you a new rule, and we will implement the new rule in our drawing. The new rule is rule number 10. Rule number 10, according to rule number 10, in any circle, if AB is any chord in the circle and PT is tangent to the circle, then the following equation is true, that PT square equals to PA times PB. Okay, again, in the drawing we have tangent PT is tangent to this circle at point P, and line segment PB cuts the circle at points A and B. So the following equation is true, that PT square equals to PA times PB. Actually, we can implement rule number 10 in our drawing. Why? Because if you focus on the at point P, from point P we have tangent PA that is tangent to this semicircle at point A, and we also have line segment PS that cuts the semicircle at points Q and S. Therefore we can implement here rule number 10. According to rule number 10, we get that PA square equals to PQ times PS. Repeat again. If we focus at point P, then we will get that according to rule number 10, PA square equals to PQ times PS. So PA is 6, therefore PA square is 6 squared, that is 36, and it is equals to PQ. PQ is 4 times PS. PS in total equals to 4 plus QS. So we substitute PS by 4 plus QS. So finally we found out that according to rule number 10, 36 equals to 4 times 4 plus QS. Here we divide this equation by 4, and we get that 36 over 4 is 9, so 9 equals to 4 plus QS. Here we subtract 4 from this equation, and we get that finally that QS equals to 9 minus 4, that is 5. So QS equals to 5 units in its length. And write down in the drawing that this line segment QS, or called QS, equals to 5 units in its length. But it is also given us the question that QS equals to QC. And QS is 5, therefore QC must be also equal to 5 units in its length. In the next step, we will join points P and C together by a straight line. Actually, it is given us the question that PS is a straight line. So if we focus on the lower side of the straight line PS at point Q, here the sum of the angles must be equal to 180 degrees according to rule number 3. According to rule number 3, the sum of the angles on one side of a straight line is equal to 180 degrees. AB is a straight line. If we focus on the upper side of the straight line AB at point Q, here the sum of the angles must be equal to 180 degrees. That is to say, alpha plus beta in total, they must be equal to 180 degrees. So we can actually implement rule number 3 in our drawing. Why? In our drawing, if we focus on the lower side of the straight line QS at point Q, here the sum of the angles must be equal to 180 degrees according to rule number 3. So which angles we have at the lower side of PS at point Q? We have this angle that is equal to 90 degrees plus the missing angle. In total, they must be equal to 180 degrees. Therefore, the missing angle must be equal to 90 degrees. Okay, in order to complete the sum of the angles at the lower side of the straight line PS at point Q to 180 degrees, the missing angle here must be equal to 90 degrees. Therefore, triangle PQC is a right triangle. So we can actually implement the Pythagoras theorem in the right triangle, triangle PQC. So I will copy the right triangle PQC in the new page, and we will implement the Pythagoras theorem on the right triangle, triangle PQC. By PT is a relation for Pythagoras theorem. According to the Pythagoras theorem, so I copy the right triangle PQC here. Side PQ equals to 4 units. We just right now found out that QC equals to 5. So actually this is the right triangle PQC that I quote from the original drawing. Again, by PT is a version from Pythagoras theorem. In this right triangle PQC, according to the Pythagoras theorem, PC square equals to PQ square plus QC square. So PC square equals to PQ square. PQ is 4, therefore PQ square is 4 square. It is actually 16 plus QC square. QC is 5, therefore QC square is 5 square, that is 25. So in total, PC square equals to 16 plus 25, that is 41. In conclusion, we found out that PC square, that is the square of the hypotenuse of the right triangle PQC, is equals to 41 units. PC square equals to 41 units. In the next step, I will copy the right triangle, triangle PAC in the new page, and we will implement the Pythagoras theorem in this right triangle, triangle PAC. PA equals to 6 units according to what is given as the question. We have already found out that the square of the hypotenuse, that is to say PC square, equals to 41 units. And we define the length of side AC as A. So actually, this is the right triangle PAC that is coming from the original drawing. We already found out that PC square equals to 41. So in this right triangle, by PT is the evolution from Pythagoras theorem. So in this right triangle, according to the Pythagoras theorem, we'll get that PC square, that is the square of the hypotenuse, equals to PA square plus AC square. PC square is 41 and it is equals to PA square. PA is 6, therefore PA square is 6 squared, that is 36, plus AC square. AC is A according to our definition, therefore AC square is A square. In conclusion, we found out that 41 equals to 36 plus A square. Here we subtract 36 from this equation and finally we get that 41 plus 36 is 5, so 5 equals to A square. Here we take a root out of this equation and finally we get that A equals to the square root of 5 units. A equals to the square root of 5 units. So you can write here that the drawing itself, that A equals to the square root of 5 units. What is the length of line segment CB? From the drawing it is very easy to see that CB equals to AB minus AC. Repeat again. The length of line segment CB equals to AB minus AC. So CB equals to AB. AB is the diameter of this semicircle. So we define the radius of this semicircle as x. And therefore the diameter AB must be equal to 2x. Okay, AB equals to 2x minus AC. AC is A and A is square root of 5. So AC is square root of 5. So in conclusion, found out that CB equals to 2x minus square root of 5. Here, this line segment CB equals to 2x minus square root of 5 units. Okay. So, in the next step, we will complete the semicircle to a circle. We completed the semicircle to a circle, and then we will extend side QC of the right triangle PQC by a straight line until it touches the circle. And we will define the touching point of the extended side QC with this circle as point M. In the next step, I will present to you a new rule, and we will implement the new rule in our drawing. The new rule will be rule number 11. According to rule number 11, in any circle, if chord AB intersects with chord CD at point O, then the following equation is true, that AO times BO equals to CO times DO. So in the drawing we have a circle. In this side of the circle we have chord AB that intersects with chord CD at point O. Point O is the intersection point. So whenever you have inside the circle two chords that intersect with each other, then the following equation will be true, that AO times OB equals to CO times OD. Again, AO times OB equals to CO times OD. We can actually implement rule number 11 in our drawing. Why? Because in our drawing we have chord AB that intersects with chord QM at point C. Again, chord AB intersects with chord QM at point C. Point C is the intersection point. So I write it down. In our drawing, chord AB intersects with chord QM and the intersection point occurs at point C. Repeat again. Now drawing, chord AB intersects with chord QM at point C. Therefore, according to rule number 11, we can implement it, rule number 11. According to, why? Because we have two chords that intersect with each other. So according to rule number 11, we will get that AC times CB, AC times CB is equals to QC times CM. QC times CM. Repeat again. This equation is the implementation of rule number 11 in our drawing. According to rule number 11, because of the fact that chord AB intersects with chord QM at point C, according to rule number 11, AC times CB equals to QC times CM. Here we will define line segment CM as B. So AC is A and A is equal to 5 times CB. CB equals to 2x 1 square root of 5. And it is equals to AC. AC is 5 times CM. CM is B according to our definition. In conclusion, we found out that according to equation number 1, square root of 5 times 2x minus square root of 5 equals to 5b. Here we divide this equation number 1 by square root of 5, and we'll get that according to equation number 1, 2x minus square root of 5 is equals to 5b over 5 squared. 5b over square root of 5. Okay. So here we'll add to this equation number 1 square root of 5, and we get that according to this equation number 1, 2x equals to 5b over square root of 5 plus square root of 5. So here we will multiply square root of 5 by square root of 5, and then we will divide it by square root of 5 in order to have a common factor with this expression. And we will get that according to equation number 1, actually, 2x equals to 5b over square root of 5, and then we will multiply square root of 5 by square root of 5, and then we will divide it by square root of 5. So in conclusion, we found out that according to equation number 1, x equals to 5b plus square root of 5 times square root of 5 over square root of 5. That is to say 2x equals to 5b plus square root of 5 times square root of 5 is 5 divided by square root of 5. In conclusion, we found out that according to equation number 1, 2x equals to 5b plus 5 over square root of 5. Here we divide this equation number 1 by 2, and finally we get that according to equation number 1, x equals to 5b plus 5 over 2 times square root of 5. Actually, x is the variable that we are looking for. X is, according to our definition, x is the radius of the semicircle, and that is the radius that we are looking for. We actually succeeded to express the value of x in terms of b. Okay, so in the next step we will join points S and N together by a straight line. So in the drawing we have peripheral angle MQS that equals to 90 degrees. Again, peripheral angle MQS, this peripheral angle MQS equals to 90 degrees. According to actually what is given as the question. Actually, according to what is given as the question, angle CQS is an angle CQS that is equal to 90 degrees. We actually extended the leg of angle CQS by a straight line. In this way we got peripheral angle MQS. When you extend the leg of the angle, you are not changing the size of the angle. Therefore, angle CQS equals to 90 degrees. When we extended the leg QC, we got QM. Therefore, this peripheral angle MQS still will be equal to 90 degrees. Because it is the same angle CQS, and we just extended the leg QC by straight line. Therefore, angle CQS is exactly the same angle as angle MQS. We just extended the leg QC by straight line. So angle QMQS still will be equal to 90 degrees. Because when we change the leg of the angle, we are not changing the size of the angle. Okay, so angle MQS also is still equals to 90 degrees. So we have peripheral angle MQS that is equal to 90 degrees. And we have rule number 5 that states that any peripheral angle that is equal to 90 degrees must rest on the diameter of the circle. I'll repeat again on rule number 5. According to rule number 5, any peripheral angle that is equal to 90 degrees must rest on the diameter of the circle. Here we have peripheral angle MAN that is equal to 90 degrees, and because of the fact that this peripheral angle equals to 90 degrees, this peripheral angle MAN must rest on the diameter of the circle. That is to say, MN is the diameter of the circle. Okay? We can actually implement rule number 5 in our drawing. Why? Because in our drawing we have peripheral angle MQS that is equal to 90 degrees. Therefore, this peripheral angle MQS that is equal to 90 degrees must rest on the diameter of the circle. But this peripheral angle MQS rests on MS. Therefore, MS must be the diameter of the circle. So I write it down here that according to rule number 5, because of the fact that peripheral angle MQS, this peripheral angle MQS equals to 90 degrees, peripheral angle MQS equals to 90 degrees, therefore according to rule number 5, MS is the diameter of the circle. MS is the diameter. The radius is x, therefore the diameter MS must be equal to 2x. So MS equals to 2x. MS equals to 2x. So in the next step, I will copy the right triangle MQS in the new page, and we will implement the Pythagoras theorem in this right triangle MQS. Side QM equals to 5 plus B. And we just write down found out that MS is the diameter of the circle, that is to say it is equals to 2x. So actually, this is the right triangle QSM that I covered from the original drawing. Here by PT is the abbreviation for Pythagoras theorem. Sin QM equals to 5 plus B, QS equals to 5, and the hypotenuse MS is equal to the diameter of the circle, that is to say it is equals to 2x. So in this side triangle QMS by PT is the abbreviation for Pythagoras theorem. We get that SM square equals to QS square plus QM square. SM is 2x, therefore SM square is 2x squared. This is equation number 2. And it is equals to QS square. QS is 5, therefore QS square is 5 squared, that is 25, plus QM square. QM is 5 plus B, therefore QM square is 5 plus B square. This is according to equation number 2. Well, according to equation number 1, we have already found out that x equals to 5b plus 5 over 2 times square root of 5. Therefore, you can substitute x in equation number 2 by the value of x from equation number 1 by 5b plus 5 over 2 times square root of 5. So we'll do it now, and we'll get that according to equation number 2. We have 2x squared, so it is 2 times x, and x, according to equation number 1, is 5b plus 5 over 2 times square root of 5. So it is 2x squared. It is equals to 25 plus 5 plus b squared. In this side of the equation, we have 2 in the numerator and 2 in the denominator, so 2 will get cancelled. So in this side of the equation, we left with 5b plus 5 squared over square root of 5 squared. Square root of 5 squared is 5. So in the denominator we left with 5, and it is equals to 25 plus 5 plus b squared equals to 5 squared, that is 25, plus b squared plus 2 times 5b is plus 10b. We'll open the brackets on this side of equation number 2, and finally we will get that according to equation number 2, (5b plus 5 squared equals to 5b squared, that is 25b squared, plus 5 squared, that is 25, plus 2 times 5b times 5, so it is 2 times 5b is 10b, and 10b times 5 is 50b. So it is plus 50b plus 50b, all divided by 5. Repeat again, in this side of the equation, after we open the brackets, we have 25b squared plus 25 plus 50b over 5, and it is equals to, on the other side of the equation we have 25 plus 25 is 50, plus b squared plus 10b. Okay. So in this side of the equation we have 25b squared over 5 is 5b squared, plus 25 over 25 is 5, plus 50b over 5 is 10b. and it is equal to the other side of the equation. We have 10b plus b squared plus 50. So here we have 10b on both sides of the equation, so 10b will get cancelled. So in this side of the equation we left only with 5b squared plus 5. It is equal to on the other side of the equation we have b squared plus 50. Here we subtract b squared from this equation, equation number 2, and finally we get that 5b squared minus b squared is 4b squared. So 4b squared equals to 4b squared plus 5 equals to 50. Here we subtract 5 from this equation, equation number 2, and finally we get that according to equation number 2, 4b squared equals to 50 minus 5 is 45. So 4b squared equals to 45. Here we divide this equation, equation number 2, by 4. And finally we get that according to this equation, equation number 2, b squared equals to 45 over 4. Okay. So b squared equals to 45. We substitute 45 by 9 times 5 over 4. Here we take a root out of this equation, equation number 2, and finally we get that according to equation number 2, this equation, equation number 2, b equals to the square root of 9 times 5 over 4. So b equals to, in the numerator we have the square root of 9 is 3, so inside the root we left only with 5. In the denominator we have square root of 4 is 2, so in the denominator we left only with 2. In conclusion, we found out that b equals to 3 times square root of 5 over 2. Only to equation number 2, b equals to 3 times square root of 5 over 2. While according to equation number 1, we have already found out that x equals to 5b plus 5 over 2 times square root of 5. Repeat again. According to equation number 1, we have already found out that x equals to 5b plus 5 over 2 times square root of 5. But we just right now found out that b equals to 3 times square root of 5 over 2. According to equation number 2. So here we substitute b in this equation, equation number 1, by 3 times square root of 5 over 2, and we get the value of x, that is the value that we are looking for. X is the radius of this semicircle, that is the radius that we are looking for. So according to equation number 1, we found out that x, that is the radius of the semicircle, equals to 5b, and b is 3 times square root of 5 over 2 plus 5 over 2 times square root of 5. Okay. So here we'll multiply 5 by 2 and then we'll divide it by 2 in order to have a common factor with this expression. And we'll get that x equals to 5 times 3 is 15 times square root of 5 over 2, and 5 times 2 is 10, so it is plus 10 over 2. So We multiplied 5 by 2 and then we divided by 2, so we change nothing. All divided by 2 times square root of 5. So here we'll move 2 times square root of 5 to the numerator, and finally we get that x equals to 15 times square root of 5 plus 10 over 2 times square root of 5. So x equals to 15 times square root of 5 plus 10 over 2 times 2 is 4, so in total in the denominator we have 4 times square root of 5. In the next step we'll take square root of 5 as a common factor from the numerator. So what is left from 15 times square root of 5 after we took from it square root of 5 as a common factor? What is left is actually 15 plus what is left from 10 after we took from it square root of 5 as a common factor. What is left is actually square root of 5 times 2. Why? Because square root of 5 times 2 times square root of 5, in total it is equals to 10. All divided by square root of 5 times 4. So here we have square root of 5 in the numerator and square root of 5 in the denominator, so square root of 5 get cancelled. And finally we get that x equals to 15 plus 2 times square root of 5 over 4. Actually we found out that the radius x of the semicircle equals to either 15 plus 2 times square root of 5 over 4, or in terms of numbers, the radius x equals to 4.8680 units. Repeat again, actually found out that the radius of this semicircle and also the radius of this circle is equals to either 15 plus 2 times square root of 5 over 4 units, or in terms of numbers, the radius x of this semicircle equals to 4.8680 units. And that is the answer to the question. So in the next step, I will summarize the lecture. So in this lecture we found out the radius of this semicircle. In the drawing, we have a semicircle. This is a semicircle. We also know that PA, line segment PA is tangent to this semicircle at point A, and the length of line segment PA is equals to 6 units, and line segment PQ equals to 4 units in length, and line segment PS cuts the semicircle at points Q and S. We also know that line segment QC equals to line segment QS, and this angle is angle PAB that is equals to 90 degrees, and this is angle SQC that is also equals to 90 degrees in its size. Again, our mission is to find out the radius of this semicircle. So, in the first step, I actually presented to you a new rule, and we implemented the new rule in our drawing. The new rule is rule number 10. According to this rule number 10, in any circle, if AB is any chord, here AB is a chord in the circle, and PT is tangent to this circle at point T. Point T is the point of tendency. Then the following equation is true, that PT squared equals to PA times PB. Repeat again. We have here tangent PT, that is tangent to this circle at point T, and we have line segment PB that cuts the circles at points A and B, and AB is also a chord in this circle. So the following equation is true here, that PT squared equals to PA times PB. Actually, we can implement rule number 10 in our drawing. Why? Because in our drawing we have, if we focus on point P, we have tangent PA that is tangent to this semicircle at point A, and we have line segment PS that cuts the circle at points Q and S. Therefore, according to rule number 10, we'll actually get here that PA squared equals to PQ times Q. PA squared equals to PQ times PS. Repeat again. According to rule number 10, we get that PA squared equals to PQ times PS. PA is 6, therefore PA squared is 6 squared, that is 36. And it is equals to PQ. PQ is 4, and PS in total equals to 4 plus QS. Okay. PS is 4 plus QS. Here we divided this equation by 4, and finally we found out that 36 over 4 is 9, and 9 equals to 4 plus QS. Here we subtracted 4 from this equation, and finally we found out that QS equals to 9 times 4, that is 5. So here QS equals to 5 units in its length. But because of the fact that it is given as the equation that QS equals to QC and QS equals to 5, therefore QC must be also equals to 5 units in its length. Okay. Then we joined points P and C together by a straight line. And then I presented to you rule number 3. And we implemented rule number 3 in our drawing. According to rule number 3, the sum of the angles on one side of a straight line is equal to 180 degrees. We have the straight line AB. If we focus on the upper side of the straight line AB at point Q, here the sum of the angles must be equal to 180 degrees according to this rule number 3. So which angles we have at the upper side of AB at point Q? We have this angle that is alpha and this angle that is beta. So according to rule number 3, alpha plus beta must be equal to 180 degrees. You can actually implement rule number 3 in our drawing. One, because in our drawing, if we focus on the upper, at the lower side of the straight line PS, we focus on the lower side of the straight line PS at point Q. Which angles we have at the lower side of PS at point Q? We have this angle that is equal to 90 degrees plus the missing angle. In total, they must be equal to 180 degrees according to rule number 3. Therefore, the missing angle must be equal. This is the missing angle that is must be equal to 90 degrees. In order to complete the sum of the angles at the lower side of the straight line PS at point Q to 180 degrees, the missing angle must be equal to 90 degrees. And because of the fact that this angle PQC equals to 90 degrees, it means that triangle PQC is the right angles. Therefore, we can implement the Pythagoras theorem on this right angle, triangle PQC. So I copied the right angle PQC in a new page and we implemented the Pythagoras theorem in this right angle, triangle PQC. So this is the right triangle PQC that I copied from the original drawing. Set PQ equals to 4 units instead. We just right now found out that QC equals to 5 units instead. So according to the Pythagoras theorem, here by PT is a version for Pythagoras theorem. According to the Pythagoras theorem, in this right triangle PQC, PC square equals to PQ square plus QC square. So PC square, that is the square of the hypotenuse, equals to PQ square. PQ is 4, therefore PQ square is 4 squared, that is 16, plus QC square. QC is 5, therefore QC square is 5 squared, that is 25. So in total, PC square equals to 16 plus 25, that is 41. So I found out that PC square, that is the square of the hypotenuse, in the right triangle PQC equals to 41. Okay. PC square equals to 41. Then I copied the right triangle PAC in a new page and we implemented the Pythagoras theorem in this right triangle, triangle PAC. So actually, this is the right triangle, triangle PAC that I copied from the original drawing. PA equals to 6 units in itself, according to what is given us in the question. We define the length of side AC as A. And we already found out that PC square equals to 41 units. According to the Pythagoras theorem, here by PT is a version for Pythagoras theorem. According to the Pythagoras theorem, in this right triangle, triangle PAC, we get that PC square equals to PA square plus AC square. PC square is 41 and it is equal to PA square. PA is 6, therefore PA square is 6 squared, that is 36, plus AC square. AC is 8, therefore AC square is 8 squared. So in total we found out that 41 equals to 36 plus A squared. Here we subtracted 36 from this equation. And finally we found out that A square equals to 41 minus 36 is 5. So A square equals to 5. We do roll out of this equation. And finally we found out that A equals to the square root of 5 units. So here AC, that is A, is equals to square root of 5 units in its length. We know that this is a semicircle, and because of the fact that this is a semicircle, then AB must be the diameter of this semicircle. Okay, so if we define the radius of this semicircle as x, then the diameter must be equal to 2x. So AB, that is the diameter of this semicircle, must be equal to 2x. Okay. AB. So AB is 2x, AC is 8, that is equal to 5, so CB in total equals to AB minus AC. I'll repeat again. The left of line segment CB is AB minus AC. So CB equals to AB, that is 2x, it is the diameter of the semicircle, minus AC, that is A, and A equals to square root of 5. So in total we found out that CB equals to 2x minus square root of 5 units. Repeat again. Here CB equals to 2x minus square root of 5 units. Then we completed this semicircle to a circle, and we extended side QC by straight line until it touches the circle. We define the touching point of the extended side QC with this circle as M. And then I presented to you rule number 11, and we implemented rule number 11 in our drawing. According to rule number 11, in any circle, if chord AB intersects with chord CD at point O, then the following equation is true, that AO times BO equals to CO times 0. Again, we have in the drawing two chords that intersect with each other. That is to say, chord AB intersects with chord DC at point O. So whenever we have inside the circle two chords that intersect with each other, then the following equation will be true. That AO times OB equals to DO times OC. Okay? Again, AO times OB equals to DO times OC. So we can actually implement rule number 11 in our drawing. Why? Because in our drawing we have chord AB that intersects with chord QM at point C. Again, chord AB intersects with chord QM at point C. Repeat again. Chord AB intersects with chord QM at point C. Therefore, according to rule number 11, we will get that AC times CB equals to QC times CM. I repeat again. AC times CB equals to QC times CM. AC is A and A equals to the square root of 5. CB is 2x minus square root of 5. And it is equals to QC, that is 5, times CM, that is B. So in conclusion, found out that according to equation number 1, square root of 5 times 2x minus square root of 5 equals to 5b. Here we divided this equation of number 1 by square root of 5, and finally we found out that 2x minus square root of 5 equals to 5b over square root of 5. Here we added to this equation number 1 square root of 5, and finally we found out that 2x equals to 5b over square root of 5 plus square root of 5. Here we multiplied square root of 5 by 5, and then we divided it by square root of 5 in order to have a common factor with this expression. So we finally found out that x equals to 5b over square root of 5. And again, we multiplied square root of 5 by square root of 5, and then we divided it by square root of 5, so we changed nothing. So in conclusion, we found out that 2x equals to 5b plus square root of 5 times square root of 5 over square root of 5. So 2x equals to 5b, and square root of 5 times square root of 5 is 5 over square root of 5. In conclusion, we found out that 2x equals to 5b plus 5 over square root of 5. Here we divided this equation number 1 by 2, and finally we found out that x equals to 5b plus 5 over 2 times square root of 5. So we found out the value of x in terms of b. Then we join points S and M together by straight line. It is given us the equation that angle CQS equals to 90 degrees. If angle CQS equals to 90 degrees, then angle MQS must be also equal to 90 degrees. Why? Because we just extended the leg QC of this angle CQS by straight line. When you extend the leg of any angle by straight line, we never change the size of the angle. The size of the angle must be also must be equal to 90 degrees. So we just extended the leg QC by straight line and we got QM. Therefore, angle MQC must be also equal to 90 degrees, exactly as angle SQS. We just extended the leg QC by straight line, therefore the size of the angles will be still equal to 90 degrees. Therefore, angle MQC equals to 90 degrees. So we have here peripheral angle MQS that is equal to 90 degrees, and therefore, according to rule number 5, this peripheral angle MQS that is equal to 90 degrees must rest on the diameter of the circle. I repeat again on rule number 5. According to rule number 5, any peripheral angle that is equal to 90 degrees must rest on the diameter of the circle. In the drawing we have peripheral angle MAN that is equal to 90 degrees, therefore this peripheral angle that is equal to 90 degrees must rest on the diameter of the circle. That is to say, MN is the diameter of the circle. Okay, so we can actually implement rule number 5 in our drawing. Why? Because in our drawing we have peripheral angle MQS that is equal to 90 degrees. Therefore, according to rule number 5, this peripheral angle MQS that is equal to 90 degrees must rest on the diameter of the circle. That is to say, MS is the diameter of the circle. Repeat again, peripheral angle MQS equals to 90 degrees. Therefore, according to rule number 5, it must rest on the diameter of the circle. That is to say, SM is the diameter of the circle. But the radius of the circle is x, therefore the diameter SM must be equal to 2x. So SM equals to 2x. SM equals to 2x in its length. Then I copied the right triangle MQS in the new page and we implemented on this right triangle MQS the Pythagoras theorem. This is the right triangle MQS or QSM that I got from the original domain. The length of QM is 5 plus B, QS equals to 5, and the hypotenuse MS of the right triangle QSM equals to 2x. It is the diameter of the circle. The hypotenuse SM equals to 2x. According to the here by PT is the equation for Pythagoras theorem. According to the Pythagoras theorem, in this right triangle QSM, SM square equals to QS square plus QM square. Repeat again, SM square equals to QS square plus QM square. SM is 2x, therefore SM is 2x square, and it must be equal to QS square. QS is 5, therefore QS square is 5 square, that is 25, plus QM square. QM is 5 plus B, therefore QM square is 5 plus B square. Okay, so here, this is according to equation number 2. 2x squared equals to 25 plus 5 plus b squared. But according to equation number 1, we have already found out that x equals to 5b plus 5 over 2 times square root of 5. So we can actually substitute x in this equation, equation number 2, by 5b plus 5 over 2 times square root of 5 from equation number 1. Because x equals to 5b plus 5 over 2 times square root of 5. We did it and we got that according to equation number 2, 2x is 2 times, x is 5b plus 5 over 2 times square root of 5, all squared, and it is equals to, according to equation number 2, it is equals to 25 plus 5 plus b squared. So here we have 2 in the numerator and 2 in the denominator, so 2 will get cancelled. And therefore we left only with 5b plus 5 squared over square root of 5 squared is 5. Okay, so on this side of the equation we left only with 5b plus 5 squared over 5. In the other side of the equation we have 25 plus 5 plus b squared. 5 plus b squared equals to 5 squared, that is 25, plus b squared, plus 2 times 5b is plus 10b. Okay, then we open the brackets on this side of the equation number 2, and finally we found out that 5b plus 5 squared is 5b squared, that is 25b squared, plus 5 squared, that is 25, plus 2 times 5b times 5 is plus 50b over 5. So, the conclusion in this side of the equation, we have 25b squared plus 25 plus 50b over 5. And this is equals to 50 plus b squared plus 10b. Here 25b squared over 5 is 5b squared, 25 over 5 is 5, and 50b over 5 is 10b. This is equals to 10b plus b squared plus 50. Okay, so here we have 10b on both sides of the equation, so 10b will get cancelled. So in this side of the equation, after we cancel 10b, we left only with 5b squared plus 5. On the other side of the equation, we left with b squared plus 50. So the conclusion found out that according to equation number 2, 5b squared plus 5 equals to b squared plus 50. Here we subtracted b squared from this equation number 2, and found out that 5b squared minus b squared is 4b squared. 4b squared plus 5 equals to 50. We subtracted 5 from this equation, and finally found out that 4b squared equals to 50 minus 5 is 45. So 4b squared equals to 45 according to this equation number 2. We divided this equation number 2 by 4, and finally found out that b squared equals to 45 over 4. Then we substitute 45 by 9 times 5, so it is b squared equals to 9 times 5 over 4. Then we took out of this equation number 2, and finally found out that b squared equals to the square root of 9 times 5 over 2. The square root of 9 is 3. So inside the root we left only with square root of 5, and in the denominator we have square root of 4, that is 2. So in conclusion, found out that according to equation number 2, b equals to 3 times square root of 5 over 2. Again, according to equation number 2, we found out that b equals to 3 times square root of 5 over 2, while according to equation number 1, we have already found out that x equals to 5b plus 5 over 2 times square root of 5. Then we substitute b by 3 times square root of 5 over 2. This is equation number 1. So, therefore we found out that x, that is the radius of the semicircle, that is the radius that we are looking for, equals to 5 times b, and b is 3 times square root of 5 over 2 plus 5 over 2 times square root of 5. Here 5 times 3 is 15, so in total the numerator we have 15 times square root of 5. And then we multiplied 5 by 2, and then we divided by 2 in order to overcome factor of this expression. So it is actually 15 times square root of 5 plus 10 over 2. Then we moved 2 times square root of 5 to the denominator here, and we found out that actually that x equals to 15 times square root of 5 plus 10 over 2 times square root of 5. So x equals to 15 times square root of 5 plus 10, and 2 times 2 is 4, so in the denominator in total we have 4 times square root of 5. Then we took square root of 5 as a common factor from the numerator. So square root of 5, we took the second and second factor. So what is left from 15 times square root of 5 after we took from it square root of 5 as a common factor? What is left is actually 15. What is left from 10 after we took from it square root of 5 is a common factor? What is left is actually square root of 5 times 2. Why? Because square root of 5 times 2 times square root of 5 is 10. All divided by square root of 5 over 4. So here we have square root of 5 in the numerator and square root of 5 in the denominator, so square root of 5 will get cancelled. And we're left with x equals to 15 times 2 times square root of 5 over 4. So actually we found out that the radius x of the semicircle equals to either 15 plus 2 times square root of 5 over 4 units, or in terms of numbers, the radius x of this semicircle equals to 4.8680 units. Okay, thank you very much.